Okay, so we are going to talk today about graphing piecewise functions. And so we have two functions here, f of x and g of x. We're going to do them one at a time. I'm going to look at piecewise functions here. F of x here, and I'm just going to graph them one piece at a time. I'll mark them with different colors, and then I'll erase. So I'm just going to graph the whole function. So I've got a square root here. Square roots I know look like this, my basic functions. And it's a negative. So negative in front means I flip it over the, oops, I did this wrong. I want one with a negative inside. That would flip it over the x-axis. I want one flipped over the y-axis. So hold on, let me edit this function. And it's important that the -1 for my transformation be factored out because, yeah, I want to apply that. So this minus inside flips it over the y-axis, meaning it's opening the opposite way, and transformed left 1. So instead of starting at 0, 0, I'm starting at 1, 0. I am going to count over my points. So the square root of, if I go -3 minus 1, that's -4. Negative is +4. The square root of 4 is 2. And now I know that I have a square root that looks kind of like this. Because of this program, I can't erase nicely. So I'm going to drop those points. But basically, I'm going like this. And I'm only keeping the part, and I'll redraw this in a second, that's after -3 here. Only keeping that part. So it starts at -3, 2. And it should have a closed circle because of this or equals here, right here. So that's piece 1 of my graph. Now we're going to move on to piece 2, which is a quadratic. I'll do that in a different color. Here, a quadratic I know is in x squared, and it's shifted down 3. This one, it goes from -3 to 1, so I can just kind of keep that. Move over 1, plug in and say 1, 2 times 1 squared is 2, -3 is -1. Because of the strictly less than part here, I'm going to put an open circle there. And I'll go -1. It should be symmetric because my vertex is 0, -3. If I plug in -2, that's -2 squared is 4, times 2 is 8, -3 is 5. And -3 is 9, 18, -3 is 15. So that's somewhere up here. And again, I've got an open circle on that end because of this. I went a little extreme on this one. Maybe should have went 1/2 x squared instead of 2. But okay, here's my little bit of a parabola. Now finally, I just graph my final piece. And this is a line -x plus 7. So that y-intercept of 7, slope of -1. And again, this is just a line going down. I have to hide my dots, so usually what I do is I graph the whole thing and I erase the part that I don't need. It doesn't work quite as well on the computer, which is why I'm undoing and redoing my points. But I will just go find the y-intercept, graph the direction I'm going, and erase. Now with the parabola, I didn't keep going. Key things to doing this: knowing the basic shape of the function, being able to find like a key point, like the starting point on my square root, and knowing which way it goes from there, or my vertex of my parabola. Now my parabola was nice because it had the vertex and I just stopped at the points where it ends. The line, again, I found the y-intercept, I plotted it, and then I erased what I needed. I only went the direction I wanted to go though. Okay, so that's your first piecewise function. They're kind of all similar. You just have to do however many graphs there are and adjust. One of the keys though is you need to plot the points and make sure that that you have accurately plotted those. You've put open circles where open circles go. And yes, your endpoints have to actually be the correct points. The rest of it can mostly be a sketch, but your endpoints must be the correct points. Okay, so this one, 2x plus 5. 2, 3, 4, 5. I'm only going in the negative direction, so I'm just going to go that way. Okay, this is the point where it's going to start on x is less than 2. So I can see I've got, goes at 2, -2, 1. I could also plot that, plug it in and get that. So I got to undo these points here for a second. So starting here, going down to the slope of 2. Again, it starts with the open circle here, going this way. And that's taking care of my line. My next one right here is a square root. It's shifted right 2. No, left 2. Shifted left 2. And ends at 2 with an open circle. So 2, I want to plug this in. 2 plus 2 is square root of 4. That is 2. So it ends at the point 2, 2. Ends with an open circle here. And then finally, I have 2 to the x. 2 to the x is an exponential function. It looks like this. Somewhere around here. It starts curving upward real sharply after the y-axis. And 2 to the 2 is 4. So I plot my point. I'm going up real rapidly. This is a closed circle because the or equal. And it looks, going up. Probably should show a little bit more curve to that. Oops. And I'm erased too much. There we go. Okay, so there's my graph. At the end of a piecewise function, I should always check and make sure it's a function. Does it pass the vertical line test? Both of these do. Okay, a key thing here. This does pass the vertical line test because it's got an open circle and a closed circle when the points are overlapping. Okay, I'm not getting a very good vertical line here, but you see the open circle, the vertical line crosses through an open and a closed circle. It's always a good thing to check that you don't have 2 closed circles. It's possible to have 2 open, but usually they have 1 closed, 1 open. Okay, so that is piecewise functions.